Section 3.7, example 2, testing inverse relationships algebraically. So if we have a function f of x equal to 1 over x plus 2, and we have another function g of x equal to 1 over x minus 2, is g of f and f inverse of x, or is g of x equal to f inverse of x? So one way to test this is to see if they're what is it called? Composition. To see if the composition of the two functions is equal to x. So we have to test both sides. So let's give it a try. So let's find f of g of x first. So f of g of x, this is going to be equal to f of g of x, which is equal to f of our inside function g of x is 1 over x, then minus 2. Our our outside function is 1 over our input plus 2. So our input here is going to be that 1 over x minus 2, then plus 2. Make it a little bit better. So we have our input plus 2 in the denominator. Numerator is just 1. So we have 1 over x minus 2 as our input. From here, we could drop those parentheses and see what we end up with. So dropping the parentheses, we end up with 1 over x minus 2 plus 2. These two subtract out, and we're left with 1 over x. In order to rationalize this, I'm going to multiply x to both top and bottom. Here in the denominator, those two divide out, and we're left with x. All right, so far we're off to a good start. F of g of x is equal to x. So far it looks like we are inverses of each other, but we still have to test the other direction. So here we're going to test g of f of x. So here we have the function g of x with the input of f of x. We have the function g of x, and our input f of x is 1 over x plus 2. Our input, or our function g of x, tells us to reciprocate our input and then subtract 2 from it. In this case, our input is 1 over x plus 2. So let's see what we have. Dropping those parentheses, we have 1 over x plus 2. And we're subtracting 2 on this side. In order to rationalize this, I'm going to multiply both top and bottom by x plus 2. Here in the denominator, the x plus 2's divide out. So in the numerator of our left part of the function, or left part of the equation, we have x plus 2. And we can't forget this minus 2 over here. Plus 2 minus 2 subtract out. What? We're left with just x. So this tells us that g of f of x is equal to x. Since both of these are equal to each other, we have inverses of each other. So we could say since f of g of x is equal to x, which is equal to g of f of x, we could say then g of x is equal to f inverse of x. And that's it. We just proved that the two functions are inverses of each other. you have any questions, please feel free to ask. Otherwise, bye.